Go ahead and put your name on it and then turn to page 1. Okay, today we are going to be learning about an exponential function. Okay, we're going to be learning how to graph them, and we're going to be learning about their characteristics. We've already learned about linear functions. They're y equals mx plus b. Then we learned about quadratic functions, and remember they can either be y equals ax squared plus bx plus c, or vertex form is y equals a times x minus h squared plus k. Today we're going to be learning about exponential functions, and they're in the form y equals a times b to the x power. Y equals a times b to the x power. Now, the x will always represent time. So like if you're doing a word problem, the amount they give you will always go in the x. The a is always the starting value. And then the b is the growth or decay factor. Okay, so the x is for time, the a is the starting value, and the b is the growth or decay factor. Now let's talk more about that b and what that is. If the b value, so the number that is raised to the exponent is the b value, if it is greater than 1, then we're dealing with an equation that is a growth. And the graph of it will look like this one. It will go up from left to right. Okay, and it's continuous, so it will continue to go up forever that way, and then over here it will continue going left forever. If the b value, which is the number raised to the x, is between 0 and 1, so like greater than 0 but less than 1, that's known as a decay. And it would look like this graph that goes down from left to right. Okay, so if the b has to be greater than 1 or between 0 and 1, what will the b never be? Correct. Or negative. Very good. Because think about it. The b has to be greater than 1 or greater than 0 but less than 1. So it'll never be 0 or negative. Yes, Tyler? Yes, that would be between 0 and 1. Okay, so now let's do these first 4 examples. They want you to identify the a value, the b value, and whether the graph is going to be a growth or decay. So for example 1, what is the a value? 4. What is the b value? 0.2. And then is this a growth or a decay? A decay. Isn't 0.2 less than 1 but greater than 0? So that's a decay. So that means for this exponential function, the graph's going to look like this. It's going to go down from left to right. Okay, for number 2, what is the a value? What's the b value? So is that a growth or a decay? Decay. 1/2 is greater than 0 but less than 1, so decay. So it'll be going down from left to right. All right, number 3, what is the a value? What is the b value? And is that a growth or a decay? That is a growth, okay, because 4.2 is greater than 1, and greater than 1 is a growth. So this graph will be going up from left to right. And then number 4, what is the a value? 4. What is the b value? And is that a growth or a decay? Growth. 2 is the b value, and that is greater than 1, so it's a growth, which means the graph of it will be going up from left to right. Okay, now we're going to do one more example. So write number 5 right here. Or actually, we might end up doing 2 more, so Just write number 5. And now write this example. Y equals 3 to the x power. Okay, so this time, what is the a value? Think about it. 1. The b is always the number raised to the exponent. So 3 is b. That means there's an understood 1 out here that just wasn't written. And so is this a growth or a decay? A growth. And so it'll be going up from left to right. Okay, now number 6. Try to fit it on this side if you can, because I'm going to be writing some stuff over here. Y equals negative 2 to the x power. What is the a value? Negative 1. Good. Because remember, b can never be negative. So b is just 2. That negative must belong to it, the a, negative 1. And so is this a growth or a decay? It is a growth because your b value is 2, and 2 is a number greater than 1. Now, the negative is going to do something to it that we'll see later. What do you think it's going to do to it? What happened when a parabola was negative? It flipped. So think about it. Normally, it's going to be a growth, but that negative is going to reflect it, so it's going to end up looking like that, a growth that gets flipped upside down. Okay, but we'll look at more of those later. Okay, now, in addition to the y equals a times b to the x, you can also have something added, something subtracted, something added to the exponent, and something subtracted to the exponent. So think back for when we were doing parabolas. What do you think this plus k will do to the exponential curve? Right, it'll go up k units. Whatever number's in for k, it'll go up that many units. So what do you think about a b to the x minus k? Down k units. Okay, now think before you spit this out. What do you think is going to happen when this is part of the exponent and it's x plus k? Remember, this is up, down, so these must be horizontal shifts. These are vertical shifts. These are horizontal shifts. Which way is this going to shift it? Left. Remember, since it's plus, it's opposite. Remember with a parabola, if it was x minus the h value, it moved right, and x plus the h value moved to left. It's the same thing with these. The horizontal shifts are opposite of what the sign says. So left k units, and then x minus k as part of the exponent is right k units. Okay, now turn to page 2. Everybody finished copying? All right, number 1. What is the a value? Correct. There's an understood 1 in the a place. What is the b value? Is it a growth or a decay? Growth. Whenever your b value is greater than 1, it's a growth. So we know that when we look at the graph, it's going to be increasing from left to right. Now, to actually get it on the graph, what do you think I'm about to do? Graph it on the calculator. So go to your calculator and type in y equals 2 to the x. You don't have to type in the 1. Just y equals 2 to the x. What? What? Look. No. 2 raised to the x power. To raise something, you hit this button below clear. Raised. Raised 2. Okay, does everybody have this typed in? I typed in the 2 first, and then to raise something to an exponent, you hit this one. No, I hit 2 first, then raised, and then I inserted the x. Okay, now once you have that, you hit graph. No, it doesn't make a U. Okay? Now see how it starts way over here at negative infinity, and then when it comes across, it starts going up forever? Isn't that what we said it was going to do because it's a growth? Where does it hit the y-axis? At 1. Okay, so I'm going to go ahead and put that on there. The y-intercept is 1, and that's one of your questions below, so you can go ahead and write out by y-intercept 0, 1. What else is 1? The a value. Okay, and didn't I tell you on the previous page that the a value is the starting value? And that's where it starts, at 1. Now, it will not always be that. Once we start adding and subtracting things in the k places, the y-intercept will be shifted. But if you just have y equals a times b to the x and nothing else over here, then that a value is your y-intercept. Okay, now to find the rest of the points, what should I do? Second graph to go to the table. Okay, now everybody look at the table for a second. Okay, once you're at the table, just look up at the board. Don't try to start plotting them, just pay attention. Okay, the first thing I'm going to do is I'm going to start at the y-intercept, which is 0, 1. We already plotted that. And then I'm just going to start moving right. Like when I go to the 1, I would go up 2. When I go right 2, I'll go up 4. Right 3 is up 8. Right 4 is up 16. Right 5 is up 32. Right 6, 64. And then look, don't the y values just continue increasing as you go to the right on the x-axis? So don't you think they'll do that forever? How are they increasing? Right, because what are they doing? They're doubling, right? 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And that's because the b value is 2. The growth factor is 2. So they're all doubling. They're all multiplying by 2. Okay, now on the left side, when we start going to the negatives, look at those y values. 0.5, 0.25, 0.125, 0.0625. What's going on? What are they all getting closer to? 0. Okay, so we're going to now plot some of these points that we can on the graph that was given to us. We've already plotted 0, 1. That was the y-intercept. Now I'm going to plot 1, 2, 2, 4, and 3, 8. So right 1 up 2, right 2 up 4, and right 3 up 8. And after that, the next number would be right 4 up 16, and I can't fit that on there. So I'm finished with this side of the curve. I went right 1 up 2, right 2 up 4, and right 3 up 8. Because earlier when I first started teaching this, when I got to mine, I can't see mine at all, so I had to copy and paste new graphs on mine. Okay, let me show you something else. As soon as you're done plotting those, look up so I can show you something else. Okay, remember it was 1, 2, 2, 4, 3, 8. Well, look, your equation is y equals 2 to the x. Well, when I type in a 1 for the x, what's 2 to the first power? And isn't that where the point was at 2, 1, 2? When I go to the x value of 2 and I replace the x with a 2, isn't 2 squared 4? And then when I replace this x value with a 3, isn't 2 to the cubed 8? And that's why when you went right 3, you went up 8. Because all you're doing is replacing the x with the x value. Okay, now let's find some points on the other side of the curve, on the negative side. When I go left 1, I go up 0.5. So left 1 up a half. And then when I go left 2, I go up a quarter of the way, which is very hard. Let me zoom in some. And then when I go left 3, I go up an 8.125. And then after that, they're pretty much impossible to plot in the right place. I just kind of put them right on top of the x-axis to show that they're getting closer and closer to 0 when you go the left side. Now, does anybody remember what that's called? Somebody already said it a while ago. I heard it. The asymptote. See how they're all getting they're flattening out right there? That's called an asymptote. And what is the equation of that asymptote? No, it's an equation. Isn't it a line? Isn't the asymptote a line, a straight line? So it's the equation of a line. Doesn't the line cross y at 0? So the equation of the asymptote is y equals 0. We learned it a while back, briefly. Well, you were never tested on it. I just talked about it. Okay, now let's talk about end behavior, domain, and range. For this next unit test, the way they write end behavior on the test is like this. It'll say, as x approaches positive and negative infinity, which means as you go right and as you go left, because think about it, isn't the x-axis just right and left? So positive infinity would be right, negative infinity would be left. They want to know what the y's are approaching. So write all this down that I'm writing. Okay, so as you go to the left side of the curve, if you're on this curve and you travel left, every y value of these points is what? Getting closer and closer to what number? 0. So on the left side, it's approaching the asymptote at 0. If you go to the right side, like if I go right here, isn't that a y value of 2? And if I go further right, isn't that a y value of 4? Further right is a y value of 8, and then further right would be a y value of 16, and then 32 and 64. So as you go to the right, the y values are doing what? Infinity. They will continue doubling forever and ever, so they're approaching infinity. Okay, now for domain and range. When you hear the word domain, you think about what? X values. Okay, so if you're on this curve and you go left, how far will it go left? Forever. How far will it go right? Forever. Think about it. You start with an x value of 1, then x value of 2, x value of 3. Won't you continue having x values forever to the right? It goes up, but it's also slightly going out to the right forever. This will be for all exponential functions. They will all have this domain. They will all go left and right forever. Their range will change from question to question because of the what? The asymptote. Wherever the asymptote is will cause the range to change. For this one, the asymptote's at 0. So doesn't that mean that you're never going to go below 0? Because the asymptote is like an invisible barrier that keeps the curve from going below it. So the lowest y value will be at 0, and the highest y value will be infinity. Doesn't go, as it's going right forever, isn't it also going up forever? Okay, any questions so far? Okay, now let's try number 2. All right, number 2, this time, what is the a value? 1 again. There's an understood 1 in the a place. What is the b value? 1/2, which makes this a decay. So the graph is going to be going down from left to right. It'll look like this. Now, if the a value is 1 and you haven't added or subtracted anything in the k places, what's the y-intercept? 1. Your a value is your y-intercept, but it will get shifted when we start putting stuff in the k's. So the y-intercept is 0, 1. How do we find the rest of the points for this? Graph it. Go to your calculator and type in y equals 1/2 to the x power. You can use alpha y equals n over d to type in the 1/2, or you could just simply type in 0.5, because that's the same thing, to the x power. Okay, we now look at it and we've confirmed that the y-intercept is 1, and we also have confirmed that it's a decay because it's going down from left to right. To get the rest of the points, what do? You go to the table. Now, you'll see that for this one, as I go to the left side, like -1, -2, -3, and so on, what are all the y values doing? Going up, and that makes sense because wasn't it going up on the left side for this one since it's a decay? And then as I go to the right side, 0, 1, 2, 3, 4, what are all of the y values approaching? Look, as I go further to the right, the y values are getting closer to what? 0. So the asymptote is at 0 because that's where there isn't. Are they getting closer and closer to 0 but never going below it to -1? So let's plot some of these points. First, I'm going to plot these nice whole numbers. So -1, 2, -2, 4, -3, 8. Okay, and then I have that side of the exponential curve. Oops. Okay, now I'm going to graph some on this side, which are the positive x values. So like +1.5, and then +2.25, and then +3.125, and then after that they're so small that you pretty much just put them right on top of the x-axis. Okay, and that's because there's an asymptote there that is preventing the curve from going below y = 0, which is the equation of the asymptote. Okay, so for this one, what is the domain? -infinity to +infinity, just like it is for all of these. What is the range this time? How low does it go? To 0. The asymptote's to 0, so that's as low as it can go. How high does it go? +infinity, because even though it is on the left side, isn't it still going up forever? So that's positive. And then for end behavior, as x approaches positive and negative infinity, which is left and right, what are the y's approaching? Okay, what are the y's approaching when you go to the left side of this curve? Positive infinity, right? As you go left, isn't it going up forever? As you go to the right side, all the y values of each point are getting closer and closer to what number? 0. All right, number 3. Okay, y equals 2 to the x plus 1. So this time, what is the a value? 1. Remember, there's an understood 1. The b value is 2 because the b value is always the number that raised to the exponent. That means this is going to be a growth. So it's going to be going up from left to right when we put it on the graph. And then what else do you notice about this equation that's different? And what will that plus 1 do to every point on the curve? Up 1. It'll shift them all up 1. Okay, so normally if your a value is 1, that's your starting value. So the y-intercept would be 1. But now where will the y-intercept be? 2. It will just get shifted up 1. So your y-intercept will now be at 0, 2. To find the rest of the points, what should we do? We should graph it. So y equals 2 raised to the x power, and then make sure you arrow over to come down from the exponent before typing in the plus 1. Right. Okay, so this time, once you see that it's graphed, you can go to the table, and like Tyler said, you'll notice on the right side, the positive x values, the y values are going higher and higher. Okay, they're going up forever. But on the left side, as you go to the left, they're not approaching 0 this time. They're getting closer and closer to 1. Okay, because the asymptote is now sitting at 1, and what caused that? The plus 1 shifted everything up 1, including the asymptote. The asymptote normally starts at y equals 0. But if everything gets shifted up 1, the asymptote is now at y equals 1. Okay, so now to plot some more points on here, I go to the table. Okay, I'll go ahead and do the nice positive whole numbers first. Like positive 1, 3, 2, 5, and 3, 9. So 1, 3 would be here. Oh, let me do it in a different color. And then 2, 5 would be right 2 up 5. And then 3, 9 would be right 3 up 9. And think about it like this. The reason right 3 is up 9 is because 3 is an x value. If I put it right here, 2 to the third power is 8, and 8 plus 1 is 9, which is why it's up 9. Okay, so there's the right side of the curve. Now to do the left side of the curve, I just look back at the table at the negative x values. And it's negative 1, 1.5, which would be left 1, up 1.5. Then negative 2 up 1.25, negative 3 up 1.125, and then after that, they're so small that you can't really put them in the right place, so I just pretty much sit them at the asymptote. Okay, so now what is the domain? Correct. It still goes left forever and it still goes right forever. The range is different from problem to problem because of where the asymptote is. This time, how far down will it go? 1, because the asymptote is now at 1 because of that plus 1 in the equation. And then how high will they go? Infinity. Okay, and then for end behavior, as you go to the left side of the curve, the y values are all approaching 1. The asymptote's at 1, and on the left side you're approaching the asymptote. As you go to the right side, the y values are all approaching infinity. Everybody got that copied? All right, now let's look at number 4. Okay, for number 4, what is the A value? Correct. What is the B value? Which means this is a decay. So the graph of it will be going down from left to right. Who can tell me where the y-intercept's going to be? 0. Because normally if the A is 1, that's where your starting point is. But if everything gets shifted down 1, it comes back down to 0. Where's the asymptote line going to be? Negative 1. Because the asymptote always starts at y equals 0. But if everything gets shifted down 1, the asymptote is now down here at negative 1. And so the equation of that line is y equals negative 1. And then the y-intercept is 0, 0. Okay, to find the rest of the points, I need to graph this and go to the table. So go ahead and graph y equals 1/2 to the x power minus 1. And make sure you're arrowing over before typing in the minus 1, because the minus 1 is a big minus 1, not an exponent. Okay, we can see, like we had already talked about, that the asymptote is now below the x-axis at negative 1. The y-intercept is at 0, 0. And then to find the rest of the points, we need to go to the table. Okay, on the left side, you'll see that all the y values are going up because the left side looks like that. On the right side, you'll see that all of the y values are getting closer and closer to what number? Negative 1. So go ahead and plot some of these points. We can start with negative 1, 1, negative 2, 3. probably because when you typed in this, you typed it in as a fraction. So if you don't want it like that, you'll need to type it in as a 0.5 instead of a 1/2. Okay, and then negative 3, 7, and that's the last point I can fit on that side. Okay, now on the right side, I can plot 1, negative 0.5, 2, negative 0.75. And then after that, I pretty much just put them right on the asymptote because it's too small of a graph to get them in the exact right location. And so that's what it will look like. Okay, so what is the domain of that? Correct. It goes left forever and right forever. What about the range this time?
0, 0.
Negative 1 up to infinity. Remember, for range, you always do how far down it will go, then how far up it will go. Okay, and then for end behavior, as you go the left side of the curve, the y's are all approaching infinity. They're going up on the left side. But as you go the right side of the curve, the y values are all approaching the asymptote at negative 1. Okay, there's no homework tonight. We'll continue learning this tomorrow. You may switch out.